Hello, everyone, and welcome to this webinar from the Global CCS Institute. We'll be discussing today the needs, opportunities, and prospects for CO2 shipping projects. My name is Angus Gillespie. I'm speaking to you from Bonnie, Scotland, and I will be moderating today's discussion. So, for those of you who are not familiar with the Institute, we're an international carbon capture and storage think tank whose prime mission is to accelerate the scale-up of CCS, a vital technology needed to tackle climate change. As you can see from the map there, we do have offices all around the world, so we are a global institute, a genuinely global institute, with deep expertise and history in the whole subject around CCS. Next slide, please. So before we begin the business of the day, let's take a moment to cover two housekeeping items. First of all, this webinar is being recorded, and I plan for it to be about 1 hour long. The recording will be available on the Institute's website in the next few weeks. As I said earlier, I'll be moderating this entire webinar, and that will include a question and answer portion towards the end of the event, and I'll do my best, we will do our best, to answer as many of your questions as possible. And I would encourage you to submit your questions as they arise using the Q&A box that's at the bottom of your screen on the Zoom control panel. You'll see it there, and just start sending in your questions as soon as you feel they're appropriate. Now, for those who might not be aware, the Institute recently published this report on CO2 shipping, and I'll touch on some of the highlights of that shortly. I should say as well, this was a report that is intended for the reader who's looking for an introduction to the whole topic of CO2 shipping. It's not a deep subject matter expert paper. There's still a lot of offices around the world who can offer that type of expertise. This is really intended as an introduction to the whole topic. So it's a good, broad introduction to CO2 shipping. If you'd like to read the report and get all the key takeaways, you can scan the QR code on this slide here at the bottom left. You'll see that, I think, in a couple of the slides as we go through. So joining us in just a moment to share their expert lens and views on CO2 shipping, we're very fortunate to have Matthias Sorhug from DNV and Thomas Minsas from Northern Lights. They'll both provide presentations after my own and then take part in that moderated discussion I spoke of. And if there's time, we'll take a few audience questions as well. Thank you. So let me launch into my own presentation. So what does the current status of CO2 transportation broadly look like, and where does shipping fit into that? As you'll see here from the pie chart, I mean, pipelines are just the complete dominant transport means at present. They account for about 95% of the CO2 that was shifted in the past few years. Shipping, as you get there, is estimated about 4%. Rail and road, very small, but that doesn't mean they're on the edge of disappearing. They've both got very important niche roles to play in terms of transporting CO2, particularly when it comes to CCS. Also, when it comes to shipping, before Northern Lights come on the scene, a very exciting development when it comes to shipping, that figure is almost entirely to do with CO2 being moved for the food and drink industry and almost predominantly in Northern Europe. So as we see Northern Lights start and then some of the efforts I'll talk about in Asia Pacific, that will really broaden and that number will undoubtedly increase. Finally, the kind of penultimate bullet point you see there is just making the point that when it comes to trains, not often used, but used in the US and Europe, a single train can carry about 3,000 tons at a time. Trucks, by comparison, Again, they do exist in sparse examples with very small, basically 20 tons of CO2 per trip. So you can see that these rail and road where there is no pipeline infrastructure or you're not by a quayside will retain a role, but very small and niche in future. Next slide, please. So despite the kind of slow start or small start that shipping has when it comes to the volumes of CO2 being moved, there are a broad set of factors that support this growth in CO2 shipping that I think I'll use a term we're expecting to see over the next few decades. So you can read these yourself, but they include basically the evolution of more adventurous, effective CO2 vessel designs based on both larger cargo sizes and variations in the pressure under which the CO2 is transported. The number of international ports with handling facilities is growing all the time, as is the development of regional CCS hubs and clusters, these types of networks where there's a third-party service for the transport and storage services. So those are growing too. And the final mention there, it's a strange one, supportive marine laws and regulation, because the driver for CO2 shipping is really when these laws are being relaxed and the ability to transfer or transport non-pipeline forms of CO2 is becoming more acceptable. So just now, really, the marine laws and regulations, it's more a barrier than an enabler. But as they're relaxed, removed, as countries come together, that will get easier. And then on the right-hand side, you can see some of the resulting advantages. They're fairly well covered in the literature just now, but it can lower CO2, it being shipping, can lower CO2 transport costs for some projects. We'll talk about that. It can improve the CCS project business case in turn, and it will again support the emergence of more and more international networks or hub and cluster developments across the world to, will service CCS. The increased project flexibility. I mean, it's the thing with shipping, largely because of its variable cost basis rather than a fixed. It's better equipped shipping as compared to pipelines to offer really useful services, transport services for small CCS projects, for CCS projects with a relatively limited life, or for those with a very erratic or flexible profile when it comes to the CO2 loads being captured. And of course, the big one, the final advantage is in the long term and probably for the world's benefit when it comes to climate action, the ability of shipping to play a major role when it comes to the management of so-called stranded CO2 emissions, describing the point where there's a country with lots of emissions, but not much in the way of natural sinks in which to store the CO2. So really, a lot of factors underpinning this anticipated growth in CO2 shipping. Next slide, please. So the pipeline versus shipping trade-off for CO2 transport, it's strongly driven by both distance and volume. This type of matrix is a common feature in the industry. This is one that's been developed in-house by the Institute itself. It's a variation on themes, and most matrices, although they vary a little, show similar results. What you'll see here is pipelines will remain, or do remain, the preferred options for short distances across most flow rates for the CO2. But as transport distances increase, shipping becomes progressively more cost competitive, particularly for those smaller and medium CO2 volumes. So you can see here just a way of reading it. And when we're looking at the left-hand side for a project, a CCS project, maybe moving about 1 million tons of CO2 per annum, anything over 500 kilometres would tend to favour shipping, whereas if that load increases tenfold to 10 million tons of CO2 per year, pipelines can be justified on an economic basis, and therefore shipping really comes in once it gets above 1,000 kilometres. While project characteristics underlie They need to be taken into consideration. Every project is different. I don't need to tell you that. Overall, this type of table, this type of matrix, which is commonly used, reinforces the belief that the future growth in CO2 shipping is likely to be underpinned by longer transport distances and smaller or dispersed emission sources, a trend increasingly observed across the global CCS project pipeline. Next slide, please. So I just wanted to touch very briefly on the costs associated with CO2 shipping. If I can get you to look at the right-hand side of this chart, first of all, CO2 shipping costs are dominated by operating expenses or OPEX. And you can see there things like liquefaction, ship operations, fuel make up the largest proportion of those overall costs. But still, three-quarters of the collective costs are variable in nature rather than fixed. So again, you're getting that feel for rather than commit yourself to a large fixed investment in terms of pipelines, there is a major role for shipping, which can be created and importantly decommissioned with much more flexibility. Because most of these costs are variable rather than upfront, shipping is less sensitive to distance and flow rate changes than pipelines. And again, it reinforces what we saw in the matrix. CO2 shipping makes much more cost sense for smaller volumes, longer transport distances, and shorter project lifetimes, supporting its role as a flexible transport option within CCS networks in early stage based developments. And then on the left-hand side, I've quoted a few costs here. Because CO2 shipping is still emerging, a lot of these are based on studies rather than experiences. The one exception being you can see the Northern Lights quotation in that kind of fawny coloured box. But otherwise, the range based on credible studies seems to move from about $9 a tonne to $50 a tonne. Lots more in the report if you're interested in that. Okay, next slide, please. So, scenarios. The Institute used scenarios as a basis for looking at potential future volumes in CO2 shipping. Often scenarios are used in preference to projections where there is considerable uncertainty, as there is in the whole field of CO2 transport and CCS projects. Scenarios, for those that need reminding, they give us a picture, they give us a feel for what's possible, not necessarily what's likely. And that's what the study wanted to examine, was taking a few scenarios, three scenarios here. You can see the kind of the way the big uncertainties of the intensity of global decarbonisation and global collaboration have been formed. So we ended up with three scenarios. And using the Institute's Genzo model, which stands for Global Emissions and Net Zero Optimization Model, we were able to actually quantify some of the futures for that. I'm afraid I've only got very limited time. I won't have the ability to go into a lot of detail, but if we move to the next slide, please, I'll just show you a few headlines here. So steady progress, as that was the one in the middle of the previous chart. It's probably closest to what we're seeing today. And even then, by the 2040s, we could be looking at 75 million tonnes per annum of CO2 being moved by shipping. As we go along the chart, unilateral world, that was based on a future where we don't see a lot of global collaboration. We don't see the intensity being maintained in the fight for global decarbonisation, and yet we still see a growth in CO2 shipping. We believe that could be based on really a reaction to the emergence of carbon border adjustment mechanisms when it comes to CO2 regulation, and also countries seeking commercial opportunities from developing their own CO2 networks. And then at the right-hand side, it does look excessive, but it actually gets very close to things like the IEA's net zero scenario itself. And we get to a figure that's over 600 million tons of CO2 being moved each year in the 2040s by means of CO2 shipping. And this is really the bright future where countries get together, the UNFCCC starts to work together strongly. A lot of the barriers to the movement of CO2 by shipping start to fall away in marine regulation, and really we start to see that upsurge, a very continued and strong growth in CO2 shipping as we go forward. I feel I'm not doing full justice to what's in the report. I would encourage you to have a read at the report and get to understand it in more detail. So that's a bit of a lightning rush through what was in the report itself. And what I'll do now is I'm going to hand over to Matthias to provide us with some insights, thoughts on CO2 shipping from DNV, recognised expert in CO2 shipping. So Matthias, over to you.
Thank you, Angus. Thanks for the introduction, and let me speak at this webinar. As Angus said, I'm business development for CO2 shipping and CCS in DNV Maritime. If you go to the next slide, I'll give a quick intro to DNV as a company. We are a global independent assurance and risk management company. We are about 15,000 employees today and operating in more than 100 countries. In the shipping and the offshore industry, we are first and foremost known as the world's largest classification society, but we are also providing independent advisory. Across the energy sector, we are providing independent advisory, certification, verification, inspection, and monitoring services, which are also relevant for the CCS industry. So if you go to the next slide, to put our company a bit into the CCS context, we are the classification society or class society for the vessels that Thomas from Northern Light will tell more about later in the webinar. In kind of the early stages of CCS, which we are currently in, what we are doing is a lot of different pre-contract type of approval services called approval in principle or general approval for ship application. And then eventually when the ships are contracted, we go into our standard classification services. Within the advisory domain, we are independent advisor for different stakeholders along or across the whole CCS value chain. We are doing, and we have laboratories across the world which are doing different type of testing which are relevant also for CCS. And we are using insights and knowledge that we have gained to develop standards and recommended practices. An important element of what we are doing in the CCS domain is being part of or leading joint industry projects, which are also an element that we are using to develop these standards and recommended practices. If you go to the next slide, just to give an overview, fair to say before I go into the details on the joint industry projects, I would just like to mention the publications that we are doing in addition to which are free to download, which we are using or to bring the insights that we have to the industry. Moving then to the joint industry projects, what you have on the screen are the ones, and there are also a few others in the pipelines. Joint industry project currently ongoing. You can categorize them into pipelines and well, maritime and offshore, dispersion, and then also within metering. Next slide, please. Just to go a bit into the kind of the technical and regulatory readiness as we see it from our point of view. CO2 shipping, and Angus was talking a little bit about it as well, has in principle been done for a long time. It was started in the late 80s to transport CO2 for the food and beverage industry on board ships. It is in principle well covered by existing rules and regulations. In addition to that, standards and guidelines, which has been developed for gas carriers in general, are also applicable for CO2 shipping. However, moving from small scale transportation of CO2, which we are seeing up to today, to the large scale CCS value chain, that introduces some new challenges to the ship design as well as operation. Can you go to the next slide? The first medium pressure CO2 carriers dedicated for CCS transportation has been delivered and are in operation today for the Northern Light project. You can, in principle, easily scale these medium pressure vessels up to 20,000 or a bit more based on the same type of technology. And then I'm in principle talking about the cargo tanks. The maturity for low pressure shipping has been demonstrating through different projects, and the first LP or low pressure vessel design was recently delivered from a Korean shipyard. If you push one more to add a few bullet points. However, in order to support reducing the cost of CO2 shipping, we see different type of technology development ongoing, in particular around the cargo tanks and the material for the cargo tanks, which will enable larger and more cost-efficient cargo tanks. Fair to add is that the cross-cutting challenges, if you can call it that, related to CCS, maybe in particular around the CO2 composition and risks associated with that, are also relevant for shipping. Last slide before I hand it over to Northern Lights. DNV are active in developing our rules and class notations for CO2 ships using the insights that we gain through project involvement. We have dedicated for CO2 ships. We have also developed dedicated class notation for offshore injection, which are a concept that there are quite a lot of activity around. In addition to this, we have also developed dedicated rules for offshore units. Thank you. That concludes the presentation from my side.
Thank you very much, Matthias. I'm just trying to get my camera back on here. There we go. All right. Thank you, Matthias. And now I'm going to invite Thomas Minsas from Northern Lights to maybe show us.
Thank you very much, Angus.
Thanks, Thomas.
Yeah, thank you, Angus. Thank you for having me as well. It's a pleasure to be here. I'm going to go through a few quick slides, a little bit about the Longship project and Northern Lights itself. So we can, I'm going to take just a little bit of time before we jump into the Q&A, which I'm sure everyone's looking forward to. So what is the Northern Lights project for those who are not familiar? So Longship is basically the Norwegian government's ambitious CCS and climate project. Its purpose is to link industry and emitting sites from, for example, as you can see on the map there, the cement factory that belongs to Heidelberg Materials in Brevik, just outside of Porsgrunn in Norway, as well as the sites in Oslo as well. It's called Celsius. The purpose there is that they got the big emitters in the east part of the country, connecting the big emitters from these industries with CCS, carbon capture and storage. So we being Northern Lights, deal with the transport and storage part of the value chain. If you could please hop over to the next slide, I can show you a little bit more about what Northern Lights is and where we started. So in 2020, the Norwegian government launched this initiative. There was obviously no one company there that would deal with this as a whole. So Northern Lights was formed as a joint venture between Equinor, Shell, and Total Energies. The partnership started in 2017, and then the joint venture itself in 2021. Our owners have a lot of experience and knowledge of CCS from the North Sea. It's been an ongoing process for at least 28 years now, for the purposes of both storing carbon, but also increasing the injection and injectivity into wells to be able to produce more oil and gas, for example, as is the case in the Snøhvit field in the north of Norway. So Northern Lights was established in 2021, and not 5 years later than that, we started our operations and are injecting. We're currently injecting and started our operations with our vessels in June of last year. We received a few of them from yard just about a year ago. So our first vessels came from yard in China in December of 2024. And we now have a fleet of 4 vessels. We've got 2 in operations currently. We've got Northern Pioneer and Northern Pathfinder. Their sister vessel, Northern Phoenix, has just left Walvis Bay in Namibia on her way up to Norway. She was delivered from yard just a couple months ago. And we have a 4th vessel coming out of yard in just a few months. If you can please jump to the next slide. So as I was saying earlier, the Northern Lights scope is basically the part between the capture facilities in heavy industries such as Heidelberg Materials, the cement factory in Brevik in the southeast of Norway, and where we pick up the CO2. We transport it to our local storage facility in Øygarden, which is just outside of Bergen. From there, it is stored in onshore temporary storage tanks, and then it is injected through a pipeline into our reservoir. The pipeline is about 110 kilometers long, and then the reservoir itself is 2,600 meters deep. As I said, this is not new technology in that regard. It is something that has been ongoing before, but our purpose is exclusively for the purposes of storing CO2, not trying to get anything out of an existing reservoir. If you could please jump to the next slide. I can show you a little bit more about what Øygarden and our facility looks like. So as you can see on the left side, that's the currently existing facility. We have one of our lovely vessels there. If you've been on LinkedIn, you may have seen one of our iconic purple vessels. I believe this is Northern Pioneer. She's sat in front of our jetty and our visitor center. So if you are interested in making the pilgrimage to our site outside of Bergen, you are more than welcome to do so. We get quite a few visitors throughout the year. You can also see that we have a number of our storage tanks on shore, and then under the bit on the right, you can see it goes out into the pipeline and under the sea. What you might also be able to see is that we have a few icons in green. Those are the parts that have not actually been built yet, but we are currently in what is known as phase 2. We have been granted we've signed FID for that and have a contract in place for a customer for our second phase of operations. So that means that we have the exciting news that we are going to be expanding and are currently expanding our facility in Øygarden. So we've got additional storage tanks on shore. We're going to be expanding to a second jetty, and that of course also means that we are going to need more and larger vessels. So that's kind of expanding a little bit about what Erik Mathias just mentioned about the medium pressure being scaled up to 20K plus vessels. We've just put in an order for a number of vessels, doubling our fleet from 4 to 8. Which is very exciting, and I encourage everyone to check out the post made about that on LinkedIn that was announced on Thursday last week. And that's it from me.
Thank you very much, Thomas. It was great. Thanks to both you, Matthias and
Thank you.
Thomas. I'm sure there's a lot of material for the audience to submit questions on. There's already quite a few coming in. But before we get there, I want to take 10, 15 minutes just for kind of my ability to ask you two some questions to open up the discussion. So if I can, just in order of the presentations, Matthias, if I turn to you first. I mean, I know DNV are in regular contact with those right across the shipping industry. So I just wonder, when it comes to CO2 shipping, Matthias, how do you see the leading operators and shipbuilders getting ready to scale up the CO2 transport fleet when they think the time is right?
I think we have seen quite a lot of activity for several years already, where kind of the traditional stakeholder, the ship owners, the designers, the shipyards, they have been developing and preparing ship designs. As you see, there are activity around developing new materials, which is a kind of key component in the cargo tanks. We also see new concepts of cargo tanks being developed, which kind of everything it's about finding ways to reduce the cost, and a part of that is also to finding ways to increase the sizes of the cargo tanks, because CO2 has some technical challenges related to other or compared to other gases, such as density and combination of temperature and pressure, which are adding some challenges and some having some barriers then for how big you can actually build the cargo tanks.
Okay. Thank you. And Thomas, just to bring Northern Lights into the discussion a bit more, it's a thing that's often speculated is how important was the demonstration of CO2 shipping to the overall longship or landscape concept at the start?
Very good question. I mean, it is basically integral into the whole process. I mean, if you can't link the emitters with the storage, the transport side of things just it's so critical to the absolute function of the entire thing. I mean, part of the service that we do is transport and storage is basically the entirety of it. So if we don't do one of those two things, it's going to be a little bit hard to link up the industry with getting the carbon dioxide stored for permanent storage. So yeah, no, it's absolutely critical, and it's been a process actually. It's been good fun. In June of last year, when we got the first cargo from Heidelberg, it was a proof of concept. It was enormously fantastic to be involved in this process. It was with close dialogue with the vessel operators, K-Line, who operate the first vessels, the crew themselves, as well as our partners in Heidelberg Materials themselves. It was a fantastic process to be a part of, and good work from all around.
Good. And I presume on that basis, Thomas, there is quite a lot of discussion and approaches from potential CO2 shipping operators right across the world. Are those people regularly beating a path to the doors of Northern Lights?
Absolutely. I mean, the fact that I'm here today is probably an example of that. There's a lot of interest from a lot of different parties that want to know what we're doing, how we're doing it, and it's remarkable to be a part of that process.
Okay, thank you, Matthias. If I can turn back to you, I asked you previously, how the operators and shipbuilders were getting ready for this uptake, and I probably can talk with confidence about when it happens rather than if it happens. Related to that, Matthias, do you see any significant first mover advantages for those operators and builders that are ready to go or do make the first moves into CO2 shipping?
I think first and foremost, I mean, as I talked about earlier as well, there are some new challenges and risks coming from CO2 being a little bit different than other cargoes. And in that respect, you're getting experience with these, how to manage accordingly, both through kind of a project execution, project new building, but also in operation. So in that respect, the first movers will obviously gain important insights from this, which I think is the most important. And I think, as Thomas was talking about, there seemed to be quite a lot of interest. We see many ship operators are eager to get into this domain, seeing it as a future business opportunity, which they would like to engage in.
Yeah, and maybe a follow on from that. I must admit, when I was involved in the work for the report from the Institute, it seemed as though there's two big pockets of area, geographical pockets. I mean, Matthias, in terms of Northern Europe and in Asia Pacific, no surprise given we think that's where shipping is going to arise first. I mean, do you feel that, first of all, would you agree that it feels like 80–90% of the effort is in Northern Europe and in Asia Pacific? And do you think that it's a similar way of asking the same question? Do you already see these companies moving into areas outside of Northern Europe and Asia Pacific?
Yeah, I think it's natural also to include the Mediterranean in that in this context. It's not only about North Europe. You see very much the same players, maybe, but you see different trends in terms of trade, I would say. You have kind of the North Europe where you see, and also Mediterranean is a bit the same, fairly short trades, medium pressure vessels. In Northern Europe, you also see there's quite a lot of activity around offshore injection, which will include potentially larger low pressure vessels, more kind of more demanding offshore operation, maybe to some degree a bit more complex infrastructure. But on the other side, you have quite big potential for reducing cost by doing offshore injection. So that's kind of the European, the two kind of trades we see there. In APAC, it's more long voyages between typically Japan, Korea, maybe down to Malaysia, Indonesia, Australia, which typically will look at low pressure, fairly large vessels as the voyages are long and the volumes are large.
Okay, thanks. And I should say, you made me think there, and just to mention to those online, there's a terrific report from Clarkson's that was released in December last year, which does look at those markets that Matthias was just mentioning. It's got a really very impressive granulated cost breakdown, still estimates, obviously, but very, very insightful cost base, so heavily quantified report on trends in CO2 shipping across the world. I recommend that to people, particularly if you're a subscriber to Clarkson. Some great work there. Thanks, Matthias. And Thomas, turning back to you, related to CO2 shipping, obviously, just want to hear how important that has been in terms of extending and expanding the range of potential Northern Lights customers. And this is where, Thomas, we're looking for you to share with us where the furthest customers you're in contact with at present are.
It's a very good question. So I think we need to kind of look into this in a number of different ways. Like the furthest away, we need to look at the geography as one. As was mentioned just now, there's obviously limitations with the pressure of the tanks. You wouldn't necessarily, if I directly compare this with LNG, which a lot of my colleagues in Northern Lights have experience from, you could have a cargo from, for example, Hammerfest in the north of Norway go all the way to Japan. That's obviously not going to be the case for CCS with our medium pressure vessels. So we're a little bit more limited to Northern Europe or Northwest Europe. And I think if you have a look at where our customers are, that gives you a bit of a good overview of the span of what we're looking at. So we've recently announced that we are going to be working with Stockholm Exergy, which is a company out of Stockholm in Sweden. So we're looking at the Baltic, and we've got customers. For example, we've got Yara in the ARA area. So you're looking at the Benelux, northern France, maybe even western France. If you start going into the Mediterranean, it's a little bit far to cater for what we currently have. But I think if you look at the spread from basically the Baltic down to maybe the northern coast of Spain, that would probably be our range distance-wise. If you look at timeline as the other way of looking at how far out we're looking at filling our capacity for phase 2. So we're looking at possibly starting up towards the end of the 20s, the early 30s, as our scope of our timeline that we're looking at currently.
Yes, terrific. Thank you. So Matthias, maybe I'll try for one question each, guys, and then I think we'll go to the Q&As, because there is a very impressive list and range of questions coming in just now. So Matthias, and maybe it's a nice closing question to you actually in this format, is What support can DNV provide to those that are interested in finding out more about CO2 shipping? I know you touched on it in your slides, but if you really had to capture that for those online, how would you summarize the advice you could give?
Obviously, we have kind of the traditional services that we are providing around the classification and support in kind of in the pre-control states on the feasibility and doing type of pre-approval work. We are providing different advisory that can support in different level of detail to different stakeholders across the value chain, which need insights to CO2 shipping. In that context, I would also like to mention that we published a white paper, fairly technical white paper on CO2 shipping in September last year, which can be of interest. Finally, I would also like to emphasize the joint industry projects that we are doing and leading, where we're gathering the different stakeholders, addressing specific technical challenges that we can solve as an industry, not necessarily each by each company, but instead we can solve them in the independent or together, and then reducing the cost of different type of research that can or are needed to support further developments of CCS. I think that's kind of sums up the kind of three different elements of how we are supporting CCS in general, but also CO2 shipping specifically.
Thank you. And Thomas, if I can, the last question in this format before we move on, and it's to do with insights and learnings. So when it comes to the whole topic about CO2 shipping, I mean, Northern Lights has the distinction of being the people that are doing it in practice. Is there any key insights from actually doing it for real that you can share with the audience today?
Another good question. I mean, first off, I think I need to explain kind of where I come from. My past experience is that I used to be an LNG operator for Equinor, and I used to do the cargoes out to Hammerfest to mostly Europe, but a little bit around the world. Now, I think it can also be kind of fun to say that there is so much interest in what we have to do in a way that I'm not used to. So I'm getting a lot of questions. For example, I'm here today. I'm speaking to you. I don't think this would happen if in my previous role, for example. So that's probably one of the biggest learnings that I have with regards to CO2 shipping, in that there's a lot of people who want to know what I have to say and my experiences, which is, yeah, it's quite humbling actually that people are excited to hear what I have to say. So I've been in this position for the past year and a half. So there have been quite a few learnings since we started, and I think one of them has to be, for me, the biggest change for me around the insight is that it is a different product than LPG and LNG. It's not an energy product, which I'm used to. It's a byproduct of large industry. So, for example, cement, remote heating, etc. That sort of thing. It's a byproduct rather than us producing in a supply chain. We're now on the opposite side. We're the end receiver of this product. So we're quite reliant on other industries that don't necessarily have exposure to oil and gas, like many of my colleagues come from that world. I mean, our owner companies are energy companies. So there's a lot of learnings from that have been quite interesting. I mean, I've learned that since operations started with Heidelberg in the summer, I've had quite a lot of exposure towards my counterparts there. I've learned a lot about that process and how they operate, and vice versa. There's been a lot of knowledge sharing. And I think because we are among the first movers, that is probably where we need to be at the beginning. We need to work very closely with our partners. For example, with our vessels, there's a very good dialogue that we have with K-Line, for example. Looking forward to the same with Bernhard Schulte, who is the vessel operators for our fourth vessel that's coming from yard soon. And I think the openness and dialogue that we need to have around this is probably because we are in the starting phase. It's a learning experience for both us as operators and also the customers as producers. And I think that's the only way that we can, as an industry, succeed. And yeah, I think the other one is, if I compare again to LNG, we're not doing long journeys. We're doing a lot shorter, more direct voyages to and from customers who are pretty much a couple of days sailing away from our storage facility. So we're looking at a lot more regular voyages to individual customers rather than a more diversified spot market where certain producers are expecting us to pick up cargoes, etc. We're looking at more long-term contracts rather than individual spot charter hires of vessels for covering a trade for a week, for example. We're looking at long-term, more dedicated voyages. And because, I mean, we all have experiences here in shipping, this industry is rather fond of its paperwork, which means that for the amount of voyages we're doing, we're generating quite a lot of documentation that needs to be followed up. So I think one of the benefits of being in a new company, our digitalization team is quite new and they're on the ball. So they've been very, very helpful with integrating our archaic shipping industry as a whole and bringing it to the modern world. And I think that's something that a word of advice to the other lifters out there. Listen to your digi team. They're smart and switched on people.
There's no getting away from AI anywhere, Thomas, isn't it?
Oh, no.
Absolutely. Okay, thanks, guys. And with that, we're now going to take a plunge into the unknown with some of the questions that have come from the floor. Well, virtual floor. I'll take the first one just to give you two guys a chance. In fact, what I'll do, Matthias and Thomas, I'll give you the question that I'll come to while I'm answering my own. So maybe to get us started, Matthias, there's a few questions about actual definitions of what low pressure and medium pressure and high pressure means in practice. Matthias, if you could think about how best to answer that, I'll come to you after I've answered my own. And then Thomas, there's a question here about how Northern Lights deals with off-spec cargoes. So if you can think about that. Meanwhile, the question that I've been asked is, what is meant with the term liquefaction fuel cost? And would that come under operating costs or OPEX? Yeah, so first of all, it would be mostly under OPEX, but let me explain what it means. So for the great majority, in fact, virtually all cargoes, CO2 is moved as a liquid. So at the quay side, there has to be a process for taking the CO2 gas that's supplied and converting it into liquid form to then be shipped. So the costs that go with that, the reason I said it's not entirely OPEX, there is, in terms of the unitized costs, the whole cost of shipping, including the facilities on the quay side that are mandatory or essential. I can look and I can see that the capex putting in liquefaction processes or facilities is about 5% of total unitized costs. And liquefaction, in terms of the fuel to run it and all the facilities and maintenance that go with it, is about 10%. So yes, liquefaction is principally an OPEX cost. It's principally a quayside activity, and it has to be done in order to prepare the cargo to move it into that liquid form for transport. Matthias, if I come to you then, can you answer that? I'd imagine for you guys it's pretty straightforward, but that just a common understanding of low, medium, and high pressures.
Yeah, there's no clear definition of these categories, but we normally talk about or call it low pressure when you're fairly close to the triple point, and maybe up to an area 9, 10 bars, and then medium pressure, which are the vessels that Thomas is operating in Northern Lights, with the design pressure of 19 and operating a few bars below that, and then you have high pressure. Which is around 40 bars typically. That's at least kind of, there's no reason why you can also operate in between these areas where I talked about now. And I think it's also fair in those are the three ones. And then you have also a final opportunity to transport as dry ice, not keep it in liquid state, which is also an area where there has or are ongoing development, which would enable you to put it in ISO containers. So, but there's no clear definition of it. ISO developed a technical report, which was published a few years ago, where a table is given, but there's no, either in this one is not saying that this is the clear definition. So it's floating a little bit exactly where you are.
Yes, thank you. And Thomas, that question about off-spec cargoes, could you
Yes,
respond to
a very
that?
good question. So in this industry, where before we load a cargo, we receive what is known as a certificate of quality or a preliminary certificate of quality. So we have a pre-aligned spec with our customers that they have to adhere to prior to us lifting their cargoes. And if in a situation where a customer produces something that is outside of that specification, that is then caught up in the preliminary certificate of quality issuance. What happens then is that their operator reaches out to me, an operator here in Northern Lights, and then I take it to our corrosion and technical manager. Basically, what we do then is that we assess whether or not, depending on the specifications of the off-spec that has been issued to us, what is the severity of it? How off-spec are we talking? Is there a heightened corrosion risk of the cargo tanks, of the pipeline? There's a whole bunch of different factors that need to be assessed there. So if something is very off-spec and has a high risk of being an acid, for example, being formed, then we would obviously be less inclined to pick up that cargo. So we would need to then assess it on a case-by-case basis to see how severe this case is before we handle it. So I wouldn't want to go into details to say if we're going to accept everything or blanket check to everything. Obviously, this needs to be assessed every single time we have one of these situations.
Okay, thank you. I'm just reading the other ones. There's a question here which I can take on the basis of the port work. It says, by 2045, what would be the split between ships and pipelines in terms of CO2 transport? So, it's looking for a percentage breakdown when it comes to shipping CO2 and piping CO2. So I can certainly tell you what the Genzo model estimated when it came to the scenarios. And again, I have to reinforce that scenarios are not projections, they're not forecasts, they're possibilities. And according to the three scenarios that we looked at, if I remember correctly, global the one that was most collaborative, where it came to the greatest level of effort on a unified basis, the one we've got up to over 600 million tons per annum. There, the split was 60% shipping, 40% pipelines. And the lowest proportion we had for shipping was in the steady state, which is more or less our steady progress, which is similar to what we see today, the continuation, really an incremental scenario, if you like. But even then, you were looking at 40% of CO2 potentially being moved by shipping in 2045. So the range is somewhere between 40 and 60%, and that's according to scenario type optimization model generation of outcomes, but that's the type of proportion. Before I move on, guys, is there anything, I mean, Matthias, has DNV done any work in this area you want to quote, or is there anything you
On
would...
the projections on,
Yeah,
yeah.
between pipelines and shipping?
No, we haven't. We have done, we have our energy transition outlook. We published a dedicated one for CCS before the summer last year. Then we looked at kind of what the projections are for CCS in general, without going into detail exactly what will be how the transportation and preferred means for transportation would be. I think it's important maybe to emphasize it's not necessarily either shipping or pipelines. This will be, if this really kicks off and there are large volumes of CCS or CO2 to be captured, we will have networks of pipelines and ships working together. So I think it's challenging also to make that kind of clear split between pipeline and ships. I think it will be a combination. Exactly how this network will look like, feeder vessels, offshore injection pipelines, etc., that I don't dare to give a prediction on.
Okay. Well, maybe a question it's, I mean, it's a DNV type question here, Matthias. Regarding impurities, which I presume is in the CO, associated with the CO2 stream, when comparing maritime transport to pipeline transport, which method is more robust? And what are the advantages and disadvantages of each method? So I think it's looking for kind of comment on the kind of exposure to impurities in the CO2 stream and whether there's a difference between kind of ship-based transport and pipeline-based transport.
I think that maybe not. It's a fairly technical question, maybe when difficult to give a clear answer to. I think the challenges are in many respects the same. It's to a large degree, it's corrosion, which is maybe the biggest concern at the moment. That would be relevant for pipelines as well as ships. I mean, in most value chains, Northern Light is also both pipelines and ships, and the CO2 composition will need to be monitored and controlled throughout the value chain in order to make sure that you have a composition which are not in any way risking the integrity of the pipelines and ships. Exactly which method is most robust, I'm not really the one to say, but I think many of the challenges are basically the same. It's and maybe at least at the moment, it's to a large degree corrosion, which is kind of the main concern.
And I suppose that's yet to be seen with shipping as well, Matthias, isn't it? It's once we start seeing significant volumes being moved that these types of issues will arise in practice rather than just from studies and analysis.
Yeah, I think I think it's with Northern Light now being in operation, we will learn a lot from that, and it's you can only do so much on desktop studies. I think practical experience, we will gain a lot of insight. How do we do this in practice and how we manage it?
Yeah. So no pressure, Thomas. Always looking for more data coming out of the project. And Thomas, I think in the interest of time, the last question. Listen, guy, those in the audience, thank you very much. There's absolutely shed loads of questions here. I'm trying to pick out the ones that are most representative. But I think the final question of the session of the webcast to you, Thomas, in terms of Northern Lights, and the question is, what are the benefits of the hybrid shipping pipeline transport approach? Would a floating operation be more flexible given the recent technology? So it's kind of two parts to that. One is about the combination of shipping and pipeline, whether that means in the short term, the pipeline out to the sink, or in the longer term, the whole kind of European highway plan where you get pipes and ships. Take it how you wish, Thomas. And then would a floating operation be more flexible given recent technology?
Excellent question. So our current model of being a hybrid solution, I mean, you both just touched upon it actually with the flexibility that the shipping operates. I mean, in your slides earlier, Angus, you mentioned the table with distance versus volume. That gives us quite a benefit of having that. Obviously, when you also then go to extreme distances for some of our customers, for example, from Stockholm, the costs of having a pipeline made for this purpose, I mean, it would be astronomical. So that's one of the barriers there. So I think you would need to have ships to be able to cater to that trade, for example. And if you, for example, have a very, very narrow system, basically, if you had, say, in the Baltic, right in the middle between Lithuania and Stockholm, just outside of Gotland, and have a storage facility there, picking up CO2 from, for example, from Finland, from the Baltic nations, from Poland, Germany, Denmark, etc. I think that and have that as a center point. I think then pipeline would be exclusively pipeline would then be a more optimal case. With where we are and where our customers are, I think the hybrid solution has to be the solution. I mean, the second part of the question was having a floating operation. It's my understanding then that you basically have a floating terminal offshore with a pipeline going straight down to the reservoir. That is a possibility. I basically have it as an offshore rig essentially as a receiving terminal. That would be a possibility as well. I am no engineer. I'm a logistician by trade. So I'll let the experts talk about the feasibility of that project. But I mean, from a logistics perspective, I think that could be quite an interesting solution as well, and just have vessels to that location. No, it's definitely one I will do a bit more research into, because I think that could be quite a interesting proposal. Yeah.
Thanks, Thomas. And thanks again to both of you for sharing your views and your answers on CO2 shipping from both Northern Lights and DNV perspectives. I'd like to also thank everybody for tuning in today. I hope you found it valuable. But I'm afraid that's all we've got time for today. If you would like to learn more about what's been discussed in this webinar, you can download a report on CO2 shipping opportunities by again scanning this QR code or going on the website. And a recording of this session will be available on the Institute's website in the days to come. If you've got any further questions, please feel free to reach out to the Global CCS Institute. You'll see on the second last line there the email address. And if you're in social media, do feel free to interact with us. Global CCS Institute is our handle on LinkedIn. So finally, thank you again, Matthias and Thomas, and goodbye to everybody online. Thank you very much. Bye-bye.